On the not-so-wonderful side of this technology lie more disturbing potentials. We can now build viruses from their genomes. We have already been able to create the first synthetic polio virus. And this technique could be used to recreate terrible viruses from our past, like Ebola and the 1918 flu strand that killed up to 40 million people. What is even more worrisome is that there are easier ways of recreating microbes. You can simply add the right genes to a close relative. That raises fundamental questions about the wisdom of publishing the genomes of deadly pathogens. To recreate polio, the team at Stony Brook University in New York bought bits of the sequence from companies that make any piece of DNA to order. At the moment, only short stretches of DNA can be custom made, so the team had to assemble a genome, which is about 7,500 base pairs long, by stitching together about 100 separate sequences. When copies of the genome were made into RNA in a quick lab reaction and put together in a vial full of cellular components that mimic the human cell, out came perfectly formed viral particles. Dramatic as it sounds, this was not a scientific tour de force. All the steps are routinely followed in thousands of labs worldwide. That means anyone armed with the knowledge of a virus's sequence, some science training, and a few common tools could recreate the virus in a test tube. What seems shocking to most people is that, suddenly, it's a reality. In Article 1 of the U.S. Constitution, we the people have given Congress the power to promote the progress of science by securing for limited times to inventors the exclusive rights of their discoveries. And this has led to the patent process. But it may come as a surprise to you that genes, human genes, can be patented. The patenting of genetic sequences raises a number of troublesome issues, ranging from individual privacy concerns to controversies over whom should control the use of DNA sequences. Scientists working with gene sequences must avoid making, using, or selling gene sequences that are covered by a patent, since a finding of infringement would result in the court assessing damages and possibly devastating injunctions. It is true that some gene patents are reasonable and productive. The gene that encodes insulin, for example, has been patented. And almost all of the insulin produced in the world today is made under that patent. So people's lives are being saved as a result of that patent. But the rush to patent every new DNA sequence has resulted in a speculative and trivial patents on gene sequences. These patents are now having the opposite effect from that intended by the Constitution. Many times the owner of the gene patent have no intention of developing medicines based on that gene. And the fact that there exists a patent on that gene prevents legitimate researchers from wanting to explore that gene because of the fear of patent infringement. The U.S. office is trying to react to these difficulties, but public knowledge and oversight is a must in this sensitive area. Like Pandora, we have opened the box, and it contains a huge amount of valuable information. We now hold the keys to understanding many diseases, and in the long run, curing those diseases. But there is other knowledge in that box that we must use to extreme caution. We will probably be very insecure knowing the information it contains for some time to come. But while it may make us uncomfortable, we should also find it both amazing and hopeful.
Well, Kevin, what did you think of that? Pretty amazing, huh?
Yep, I'm pretty impressed with whatever DNA put that Pandora lady together. Now she's an amazing machine.
Hey,